Hi, welcome back. We're talking about models of atomic theory. We've done orbital diagrams, energy level diagrams, electron configurations, and where we're moving now is cleaning up our topic of electron configurations by addressing elements that go through the F block. We're not going to look at the pre-AP level at landing in the F block. Rather, we're going to just look at traversing the F block. Now, the other thing we're going to do is look at a shorthand way of doing our electron configurations. Now, I designed a periodic table here to show you how the F block squeezes in between the S block and the D block once you're at period 6 and period 7. So remember, that would be the 4F, and this would be the 5D. All right. And right in this area here, I'm going to be honest, it does some funky things. It goes into the 5D and then they change their mind and go back to the 4F. So we're not going to be looking at that. This is slightly simplified from what you would actually see in this area. But since we're simply going through the F block, it works quite well. And we're going to start with tungsten. Now, tungsten lands right in here, so that's where we're headed. So we're going to start by going 1s. So we go 1s2, 2s2, right through the 2 block. You should know how to do this by now. Then we cross the ravine and we do 2p6. Wrap around and we've got 3s2. Cross the ravine and we've got 3p6. Gets a little tedious. Then we got 4s2, cross the ravine. Remember, you go down 1 when it's D, so it's 3D. Since it's period 4, it's 3D. Going to go all the way through to 3D10. Then it's 4p6. Then it's 5s2, 4d10, 5p6. So we're through here. Then we're at 6s2, which is right here. Now here's where we're just going to kind of cheat a little bit and go right into the 4f block. Since we're going all the way through the F block, through 4f14, it works just fine. And then we end up at the 5d, right? We're in the D block, and if it's the 6th period in the D block, it's 5d4. Okay? Now let's try gold. Gold is right here. So basically gold is the same thing. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10. Do you follow the periodic table? So that's where we are right now is 4D, then 5p6, 6s2, go all the way through the F, 4f14, and now we're in the 5D, but this time it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 5D, 9. Okay, so that's how we handle the F block. All right, a simplified F block. And that also gives you an indicator of what the periodic table looks like when you've got that F block, internal. All right, let's look at abbreviated. You won't be able to do too many abbreviated because if we're asking you a question on how to do electron configuration, we want to make sure you know how to do the whole thing. But here's how you would do an abbreviated. What you do is you go to the previous. We're not talking about when we do ions going to the nearest. With this, you always go to the previous noble gas, and then you pick up the trip from there. So instead of walking through the whole periodic table, it's like a friend gave you a list part way. So if we do antimony, antimony's 51. The noble gas that's before that is krypton. So we're saying it's the electron configuration of krypton, and then we're going to pick up the trip at 5s2. Then we go into the D block, it's 4d10, and then 5p3. So it'd help if you had a periodic table next to you while you did these. If we are doing palladium, palladium's element 46, you look at the previous noble gas. It's not like we're making anions and cations. It's always the previous noble gas. And then you pick up the trip. We're in the 5th period, the S block. Then it's 4D, and palladium is in 8 electrons. All right. Now, mercury would be way down. Let me find mercury. Oh, there it is. Mercury is the previous noble gas to mercury is xenon. Sorry, looking on the periodic table and I'm not finding mercury because I'm looking on the edge. Okay, now if we start at xenon, xenon ends in the 5th period, so we're going to pick up at 6s2. Now remember, this is when we hop off and go into that F cul-de-sac. So we're going to go 4f14, and then we're going to pick up at 5d10. And that's how we would do mercury. Now, there's one last thing I want to talk about, and that's looking at a configuration and finding the elements from that configuration. So it's like going in the reverse, is identifying. Now, we're not looking at ions, we're simply looking at elements. Unless we told you it had to be the ion, that we'd have to specify that. All right, so what we do is, all you have to do is look at the ending. So you go to the 3rd period on the periodic table, you look at the P block, and you'll need a periodic table to do this, and you go in 3. So if you look at the 3rd period, the P block, go in 3, you're looking at phosphorus. Go to the, here it's the D block. So if it's the D block and the number in front is 4, that must mean that we're in the 5th period, right? Because it's a period number, that 4 is equal to the period number minus 1. D block, go in 7. So 1, 2, 3, 4, 5, 6, 7. I'm seeing RH there. Now there is another way, there is another way to do this than, looking at the periodic table like that and counting on the periodic table. You can simply add up all of these numbers and add up 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 2 plus 7, and that equals the number of electrons. And that would be the other way that you could identify it. Okay, this one ends in 6p3, so I'm going to go to the 6th period. I'm going to go to the P block and go in 3, and I see bismuth. Okay, and then this last one, because it ends in D, if it's 6 in front, remember it must have been the 7th period. So I'm going to go to the 7th period, the D block, and I'm going to count in 5. And I get BH. And that is borium. Okay? So hopefully that gives you an idea of how we're going to be using these electron configurations. We'll have lots more practice in class. Talk to you later, kiddos.